how much we can do. DPP, any question, doubts are there? Anyway, you can subjects, networks, suppose you are attending. Actually, I show you all your names before class started. Okay. Yesterday also I showed him. Yesterday I bring him and I show, without starting the camera, I show all your names and all those things. So that he will get some fear. Okay. So yesterday homework. We'll see, Anuj, depending on the time available, how much we can do. DPP, any question, doubts are there? Anyway, you people are in group, you can ask me anytime. I will send you key, don't worry. Okay, see, this is the homework I gave in the last lecture. So this is done. We have done this, and we need to modify this program to multiply two numbers. Right. Simple change. Simple change. Yes, Chavra, we can take it. Please listen. Simple change is yes, Ganesh, that S and H circuit, what we call integer and floating representation, whatever extra parts is there, I will take one class only and I will bundle that. Okay, with some name I will add it, don't worry. Those are small topics, nothing to worry much. So now, what I want to say is, right, multiplication is nothing but adding the number n number of times. How to do multiplication? Suppose you want to do m into n. You can add m n number of times. That will give you multiplication. This is the basic thing. See here now. Earlier we added n numbers. Now you should not add n numbers. You should add the same number n times. Understand the difference for multiplication and addition of the previous question. Previous question you have added n numbers. Now you are adding the same number n times, which will give you multiplication of the number with n. So for that, small difference kya. So here it is the same, okay. But here you should not increase every time. You should add same number n number of times. Yes, INX H is not required. So loop here went to INX, but here your L1 will go to not INX, it will go to add. This is the simple change. This is the simple change. Yes, is it clear? We don't increment this multiple times here. Once you increment it, see here, see here. First you take the first number. Actually, it is not count. It is here first number. First number is copied into C. Then XOR A with A. A is made equal to C. Move B comma A. That is to store the higher order byte. Then increment H. That is the first byte is copied. The second byte is copied now. Second byte is copied. Second address we are there. Now add M. The second byte is added to accumulator. Okay. So how many times you add the second byte? C number of times. So jump on no carry to loop to decrement C, no 0, go to L1. You don't increment every time. Previously we increment every time. Previously you are moving to new number every time, but here you are adding same number every time. That's what that see simple one line change will give you multiplication. Tell me, is it clear or not? How many of you have done this? Okay, forgot you're tired, and because it is not coming in exam anyway, no problem. But you got the logic right? You got the logic correct? Fine. So shall we move further? So, okay. So the next part we are going to discuss is I/O interfacing. What is the meaning of I/O interfacing? The name may sound good, okay? Name may sound good, but I mean sound different. But what is the meaning? It is simply how to connect I/O device. I/O device means input-output device to your microprocessor. What is the meaning of I/O interfacing? How to connect input and output devices to the microprocessor. That is given by I/O interfacing. Everybody understand or not understand? So in this topic, we will be discussing how to connect the peripherals, external peripherals like I/O devices to your computer. Okay. So for that, let's see what are the techniques we have to make the interfacing of I/O devices. For that, first thing we should know what are the different I/O interfacings we have. Just go through this. Just go through this. I will explain you. One by one, I will explain every point. Don't worry. So first question. First point, not question. So what is the first point? You can connect I/O device by two methods. It is not only for 8085. Generally, in your computer architecture, that is now CO is coming now. In that also it will be useful. Okay. So there are two techniques to connect your I/O device to the computer. So two ways. One way is listen here. Please listen. In your 8085, you have the address bus. What happened? You have an address bus. For that, you have 64 KB space. 64 KB. You can connect devices. I mean, you can generate 64 KB different addresses. 64K different addresses you can generate. In that address space, some part used for memory. Memory means RAM and ROM. Some part is used to connect I/O devices. Okay. In the total range of how much? Total range of 64K. Some part can be used for memory, some part can be used for I/O. Then it is called memory mapped I/O. What is the meaning of memory mapped I/O? Your I/O device is also treated as a part of memory only. You understand this point or not? I/O means what? Input output devices. The devices which read the data or write the data into the computer. Okay. So this is one thing called memory mapped I/O. The another way is listen here. Your 16-bit address is there now. That is used for memory. and 8-bit address is used for IO, and we use the signal called IO by M bar. This signal can be used to classify if it is 0 memory operation, if it is 1 IO operation. So here IO and memory are treated separately. Here IO and memory are treated separately. This is what we call memory mapped, sorry, IO mapped IO. IO and memory are not same. This is separately treated and the other one is separately treated. So now let us see. So firstly, in this, the device, the device address is 16-bit. Okay, please, IO device is treated same as memory. Thus A0 to A15 lines are used to generate the address. That is same as memory. Okay, treated, IO treated same as memory. I will write these points. IO devices can be interfaced by two methods. First one, memory mapped IO. Here, memory and IO are treated in the same way. Then another case is what? IO mapped IO. I don't know, sometimes my writing is very good. What is the reason? I don't know. But sometimes I tried, but I'm not able to write. Here, IO and memory depends on mood of this pen tab, I think. IO and memory are treated separately. Okay. Is it clear? Oh, tomorrow is weekend. Fine. So let's move to the next. So the first fundamental difference you understand here, the memory and IO are treated in the same way. But here IO mapped IO and memory are treated separately. So in this, the device address is 16-bit, that is A15 to A0 are used to generate the address. Here only 8 bits. Okay, you can use any one of these 8 bits, A0 to A7 or A8 to A15. It is up to our wish. Okay, see Aditya. Okay, so now listen here. Here, because it is a memory operation, normal memory read, memory write, all these control signals same used for memory and IO also. But here we use the control signal IO read, IO write for using your IO interface. Next, that is IO mapped IO. Here, because it is part of memory only, your IO is also part of memory only. We use any data transfer instruction like load accumulator, store accumulator, move mcomr, any data transfer instruction can be used. But here only in and out. For 8-bit address, you have only in and out, and that too. Okay, that is see here. Next point is same. So here the data transfer can take place between any register and IO device. Data transfer can be between accumulator and IO device only, because in and out instructions communicate with whom? Accumulator only. But move R comma M, this will communicate with any register. Next, here the maximum number of IO devices. If you want all total memory can be used for IO. Okay, but it is not a valid condition. But you can say maximum possibility is 6 by 536 to power 16. But here maximum number of IO devices is what? 256. Why? Because it is a 2 power 8. We have 8 bits now. So execution speed using LDA and these things, you know this T states business already. So decoding 16-bit address may require more hardware. If it is 8 bits, it may require less hardware. That's all. These are the basic differences between memory mapped IO and IO mapped IO. So let's move further. Is it okay? Not copied. They are using address space of memory. That is how you need to say. You have memory address space, all zeros to all ones. In that, some space is used by IO devices. What do you mean by pins, Asif? What do you mean by pins? IO device is any IO device. It will have input and output device. If you want to give the input, data line is required compulsory. So let's move to the next one. PPI. Programmable peripheral. What is that? This means interface. Programmable peripheral interface. How you use it means I didn't get you. How to use it? Please understand, these are the two techniques to connect input output device to the computer according to your convenience or your requirement. To the computer according to your convenience or your requirement, you connect by any one of these methods. These are the methods to connect the IO device to the computer. So programmable peripheral interface. Intel 8255. What is this? Is called PPI, Programmable Peripheral Interface, or PIO. What is PIO? Programmable Input Output Device. Okay, Programmable Input Output Device is a 40-pin IC used to interface IO devices to 8085 and also 8086. It is used to interface IO devices to the 8085 and 8086. Okay, so now what is that? Let us see its internal structure. Okay, this is what we call, what is that? 8255 internal structure. What is the use of this? I will explain one by one. See here. इसका use क्या? You can connect different I/O devices at the port for effective communication between your I/O device and the computer. This fellow will act like a mediator. This fellow will act like a mediator to help us effective communication between whom? 8085 and your I/O device. Beach mein kya? He will take like a interface. He will take care of the communication. Okay. So now see here. It has 4 ports. Ideally 3 ports only. Port A, which is PA7 to PA0, and port C upper, which is PC7 to PC4. Port C lower, which is PC3 to PC4. Port B, which is PB7 to PB0. Listen. It has 3 8-bit bidirectional I/O ports. Okay, what are they? Port A, port B, port C. In that, port A and port C upper are considered as group A. Port B, okay, port B and port C lower are considered as group B. 1 minute. Okay, see here. Port A and port C first 4-bit, sorry, upper, that is P7 to PC4. Is it visible? PC7 to PC4. This will comes under what is that first group. Similarly, the second part may PC3 to PC0 and PB7 to PB0. These 8 bits will comes under port B. Okay, group B. Right. So now come to here. Here you can connect any I/O device. What is the advantage here is the device need not wait for the CPU to read the data. It is having some buffer where it can store the data also. Okay, I will explain everything. Just wait. So this group A contains what? This box and this box. Group B contains this box and this box. Okay. So these 2 boxes together is called group B and this is group B. Each can be controlled by this control boxes. So total will be controlled by this read-write control logic. It contains again these many number of input bits. I will explain one by one. Read bar is used to read the data from this I/O devices to the computer. Write bar is used to write the data into the 8255 or I/O device from the computer. A1, A0 have 4 combinations now: 00, 01, 10, 11. Based on the combinations of 00, 01, 10, 11, they will select any one of them, whether port A or port B or port C or another thing called CWR. I will explain what is CWR. Just wait. Reset pin is used to reset the system. CS bar is used for chip selection. If it is 0, then only system will work, otherwise it will not work. For power supply, you need 2 pins. And bidirectional data bus requires 8 bits, that is 8-bit, that is for communication between CPU and I/O devices. He is taking care in between. He is like a, what you said earlier, same thing, interface between them. Okay, yeah, mediator, settler. Now you observe here, what are the 40 pins of 8255? Okay, so these are the pins of 8255. Already we have discussed. So port A0 to port A7, 8 pins, read bar signal, write bar signal, chip selection, reset, ground, A1, A0 are used for address selection, that is port A, port B, port C, and PC7 to PC0, PP0 to PP7, and VCC. That is, your all 40 pins are covered here. All 40 pins are covered in the 8255. Okay, so that is a 8255 pin diagram. Now let us see how to use this. How to use this. Listen here. 8255 contains 3 8-bit ports or 4 2 8-bit ports and 2 4-bit ports. All of them can be configured either as input or output devices, that is total 16 combinations. By using control word register. What is this? I will explain. So you can make it into two parts. Total 4 different are there ports. Any one of them can be output port. Any one of them can be input port. 4 zeros to 4 ones you can say. So 16 possible combinations are there here. So now let us see what is control word register. Who is semantic? Okay. Right. So now see here. Right now see here. IO port assignments. That is, see here, A1, A2, A0 are the selection lines which will select. Please listen. I1, I0, A1, A0 are the selection line which will select the particular port. If it is 00, port A, 01, port B, 10, port C, 11, you can say command register or control word register. What is the meaning of control word register? Is CWR. So when A1, A0 or 11, we can access the control word register. What is this control word register, sir? It can be used to make any bit, any port as an input port or output port. For that, we use take the help of control word register. So let's do that. Now, where is that? Now, I wait. Yes, outside. Very good. I thought of trying the headphones are not there. Okay, leave it. So listen here. This is what we call CWR. format. How to write the data into CWR, I will explain. We will do the programs. We will do the programs of interfacing. Don't worry about it. So listen here. Listen here. This is your CWR format. So this is the bit 7. It can be 0 or 1. Okay. If this particular bit is 0, it is BSR mode. What is BSR mode? I will explain. And if it is 1, it is IO mode. It is IO mode. Okay. So please listen here. Today only I used in YouTube session. I didn't feel comfortable with that. Mask. Yes, Asif, you are correct. So listen here. So if it is 0, it is bit set reset mode. If it is 1, it is IO mode. It is IO mode. Okay, what is bit set reset? What is BSR mode? What is IO mode? We discuss it. For time being, leave it. Now please listen. Your 8255 can operate in 3 different modes based on your requirement. We use any one of the modes. Please listen here. 8255. Okay, 8255 can operate in 3 different modes. They can be 00, 01, 10. Okay, or 11. Based on these 2 bits, we have 3 modes. Each mode is having one meaning. We discussed that. Next, this bit will tell you a particular port, that is port A, is output port or input port. Like SIMRIM instructions mein humne kiya na, similar method. This bit can be used to make a particular port A either as an output port or input port. This bit is used to make port C upper part as output port or input port. This bit can be used to make port B. Okay, this is used for port A mode selection. Okay, where is that? This one. This is used for port A IO selection, that is input output. This is port C input output. This is for port B mode selection. It has only 2 modes. Okay, mode 0 or mode 1. Then IO mode, IO function of the mode, that is whether it is output port or input port. This is also output or input. When we take the example, it will be clear. Okay, for example, if you have 101, 01, 110. Suppose this is the data I loaded. How computer will understand? It is IO mode. It is mode 1 for port A. Port A is output port. Port C is upper is input port. It is mode 1 for port B. What is mode 1? Mode 0, I will explain. This will be like port B is input port and port C lower is output. So according to your requirement, you just to modify this bit so that function will be modified. Is it clear? Okay. So now this is one method. Another is you came to class to ask this, Vishnu. So see here. Now 8255 microprocessor operating modes. In that there are 2 modes. What are they? Bit set reset mode, BSR, bit set reset mode. In the bit set reset mode, simple rule, set and reset ka matlab kya? To make output 0 or 1. So this is used to set or reset. Set or reset which port? Port C. Okay, only here please understand, when this bit is 0, these are don't case, it is of no use. Okay, these 3 bits, they can be all zeros, 0, 0, 1 to all ones, which will select port C 0 to port C 1 to port C 7. So to set or reset any bit in the port C, only port C, not for any other it is possible. Only for port C it is available. To set or reset any particular bit of a port C, we can use this mode. What is that? Bit set reset mode. In that case, D7 must be 0. If you make D7 is equal to 1, then it is called IO mode. That we are discussing now. Here we have mode 0, mode 1, mode 2. Three modes are available. Okay, your designer has given the feature to only one of them. Okay, why one, only one? It can be anything. Okay, different ports are having different features that we see now. Okay, he likes port C. Vishnu, I have already done one session yesterday. He is there or he went? Listen. So we have three modes. We have three modes. IO mode में mode 0, mode 1, mode 2. Mode 0 is a simple or basic IO mode. It is a simple or basic IO mode. Here, port A, port C can work as either as an input function or output function. The outputs are latched, inputs are not latched. Okay. It has a interrupt handling capability. Please listen here. Actually, it is a bidirectional, right? Outputs are latched का meaning क्या? In this particular mode, uh, you whatever you are sending the data na, yeah, latch or flip flop you are having, that can store the data coming from the cpu. Okay, so what is the relation between interrupt and IO? Interrupt and IO ka relation kya? Because suppose your IO device want to communicate with the processor, then IO device will send one interrupt to the processor. Then the processor will accept the interrupt and send the data or whatever required job. This is called interrupt driven IO interface. So whenever the computer want to access it, because see here, IO devices are there, CPU is busy with its time. So there is one method called polling. Polling ka matlab is every time computer will give some time for IO devices, go back and work its job. Completed again some time, like a round robin fashion. This is a polling method. In this method, what happens? Time will be wasted, or you need to wait for more time, or when it is not required, also it will come into picture. These things will happen. So the another way is interrupt-driven IO transfer. To transfer any data from IO device to computer or computer to IO device, we send one interrupt. CPU will accept the interrupt and respond to the interrupt by sending the required data or reading the required data. So I want to give you one thing. What is that? Read bar signal meaning is read from IO to CPU. Write bar. What is it meaning? Write from CPU to your IO port. Okay. So the now see here, this is a basic IO mode, that is mode 0. Next mode is handshaking IO. No, don't read that. First, let me explain. Handshaking IO or strobed IO mode. Strobed IO ka mode ka meaning kya? So when I send the computer, when I send the data, suppose this is the IO device. What is the IO device? Printer. Okay, for printer is sending your data. For example, data is sending to the printer, computer is sending the data. Okay, so before sending, it will send a strobe signal. Strobe ka matlab kya? Are you ready? Then the printer will say, yeah, I am ready, you can give my data. Okay, it will print it. So it can be like this also. No, I am busy with the typing or printing something else, you wait for some time, then it will give this acknowledgement signal. This is called handshaking protocol. Yesterday someone asked me, or strobed IO method. Another method is what? There is no communication. It will send the data at any time. It can receive data at any time. In this case, there is a chance of loss of data also. When this device is not ready, there is a chance of loss of data also. Okay. Is it clear? Now, Another mode I want to say is which data means CPU sent data. Whatever sent the CPU has sent that data, printer is not ready to receive it. What happens? The data will be lost. Yeah, acknowledge ka meaning I am ready. Okay. There are different, we discussed that. Another is yeah, that is also similar. Strobe is used there to read the data similarly to avoid the transient states. It is a technical name. Okay, mode 2 is a bidirectional IO. Okay, in this mode, only port A is having this feature. For what we call this mode, only port A, port B are having these features. Port C cannot be used. How port C is used to generate these handshaking signals? We take help of port C. So here, port A is can have bidirectional. Port C is used for generating handshaking signals, and port B can be in mode 0 or mode 1. Port B is not having the facility to be in the mode 2. Mode 2 का meaning क्या? Bidirectional data transfer. Bidirectional data transfer का meaning क्या? Generally, to transfer the data from one computer to another computer, networking cases, we use this bidirectional data. Okay. Now, so here outputs and inputs both are latched, meaning understand. So when you transfer the data, it can save it. When receiving the data also, it can keep it. Okay. So now you cannot wait. Why? It is sim instruction. I'm sorry. So now you can understand easily. Everything will come. I'll just have some patience. Port A, port B, everything will come. Okay, just wait. Now you see. I'm again repeating that. Okay, now you can understand better. This bit is 1, IO mode. So port A can be either mode 0, mode 1 or mode 2. This is port A can be input port or output port. This is port C, input port or output port. Port B can be only in 2 modes. This is for port B. This is either output or input. So this is IO, whether port C lower is output or input. Okay. So if we discuss like this for some more time, we will not be able to what we call visualize the thing. So let's take the examples and do it. This is the fundamental theory. I don't believe in theory much. So let's take one example and write a program. So where is the question? Interface an analog to digital converter to 8085. Interface an analog to digital converter to 8085 to measure temperature. These questions can come in your ES. Still, they can give you in the conventional part this kind of questions. Okay. And display the results. I'm sorry. Using 8255. Using 8255. Okay. So let's do it. Port A. Please listen. Yes, Sadhya. Correct. Port A address is 80 hexadecimal. Assume Port A address is 80 hexadecimal and what we call display connected to port B. Okay, is it clear? So let's take this problem and do it. How to do it? Let us try. .8085 is your processor. For this, you should connect another. What is that? 8255. Both of the friends are having some communication. Like this. Okay. What is this? D7 to D. D7 to D. Okay. And you have the address pins A15 to A8, which are how many pins? A8, 8 pins. Okay. And you are doing IO operation. IO by M bar should be 1. Okay. And your read bar signal should be 0. Read bar signal should be 0. This is given to your read bar. So whenever it is 1 0, it will generate 0 here, which will do the read operation. IO read signal. Okay. Similarly, for IO write, what to do? Write bar signal. This will give you IO write bar. And here, A1, A0 will be used as it is. For chip selection, okay, for chip selection, we use one AND gate. 80 is given, right? So you take this one and please understand this is A7, A3. Okay, you can use a higher bus or lower bus. I already told you, na, for in and out instructions, I told the condition. What is that? We can use either A15 to A8 or A7 to A0. Please understand, sir, D7 to D0 and A7 to A0 same na, sir. I am writing after ALE signal. This is after ALE. Please understand. Okay, why this is 1 and remaining all zeros? Because examiner has given the address is 80 is the starting address. I use that. Okay, and you can reset the system by using reset out if required. You can connect that reset also. Okay, so this is connected. Now at the port A7 to port A0. Okay, so here I connect the digital data. What is that? Analog to digital converter. It can be any D2A converter we have discussed. Okay, D7 to D0. Okay, this can be coming from nature, like temperature sensor, like your RTD, thermocouple, whatever. You take any thermocouple like that. And you have some instrumentation amplifier, because these signals are generally weak. From nature, you are sensing the temperature, you are converting this into voltage, and this is amplified and given to the ADC. Okay, it can be RTD, thermocouple, anything, any temperature sensor. So it is converted into according to your requirement and given to the ADC. Now ADC will have two things. Generally in any ADC you have SOC and EOC. That is, when I say start of the conversion, I will give a pulse. Then computer will start, then ADC will read this data and start the conversion. Once a conversion is completed, in return, this bit will be made equal to 1. That is done by, that is available in your ADCs, which we discussed in the basics, if you remember or not. Okay, so port A, wait, is that 1 minute? Wait. Arey. So for this purpose, I am using the bits port C 7 and port C 0. Here 2 bits only used, not all the bits. Okay, here all bits are used, all the 8 bits of the bits. Now port B is there, na PB7 to PB0. PB7 to PB0. Port B is there, na port B will give the output. Okay, that I will give to which one? Binary to BCD converter, and from the BCD, very good, we will give it to 7 segment display. If you have another DAC, what is the use of it, man? We want to display the result, whatever you are getting, convert into digital format, and you are displaying the result. So this is the how you do the interfacing to the system. Okay, wait. Now, how we should write a program? We should write a program. Job is not done. Only connections are done. Now we should write the program to start this. We only should give start, and we only should read end. We should only read this data and give it. This job is to be done by us now. Now we are writing the program of it. Is this point clear? Right. So Aditya, tell me, what is your doubt? Is it cleared? It is chip selection input. Chip selection is at the address of 80H, na? 40 is at 80. 80, 81, 82, 83, it will select it. Chip selection is to select this chip. It will not be selected for other addresses. A2 is not there. Take here A2. It is a A7 to A now. A2, it is A1. A7 to A2. Okay, shall we start? Shall we start? So, yes, you can connect, but how it will understand the number data? How it will read the data, how it will write the data. You can interface directly means, please, there are some processes now which are internally having ADC and DAC. Okay, so whatever you see, you need to synchronize the data coming from here and sending by your processor. Okay, you can connect here. Suppose you can connect at the address of 80 directly this device, nothing wrong. You can enable it. So whenever it comes, it can read the data also. Okay, so but here the proper communication will take place. Okay, so now let us see with the program. I think it will be more clear for you. What is Ganesh doubt? Then why are you asking? Sir, did you learn digital network on your own? Yes. In fact, I have not studied any textbook also. Okay, I mean with what we call analysis only, I am able to do that. I mean First, I learned some basic part, but now whatever now in the sense of over a period of time, whenever I get the doubts, I used to clear from internet all the sources. But most of the things self-learning only. Self-learning in the sense from analysis by doing the problems, by teaching n number of batches, everything will comes into picture. Analysis is our own. Okay, I can say I have not studied read any book of networks, any book of digital also, not even any textbook. Okay, but I suggest you some books. I know what is there in the books in the sense fastly I can say that. So I can suggest some books which are good or not. So few books I refer for few points. Like Tosi is there in that some topics are good. Few I can take. Okay, so let's move. So firstly, let's start with the control word register. Okay, so D7, D6, D5, D4, D3, D2, D1, D0. Okay, so let's write on the top. And another problem is you people are very good listeners. You can learn betterly. I am not very good listener. I am very doubt-minded. Even anyone teach me also, I will get n number of doubts. That's why I give more priority to your doubts. So other person may not be able to clear my doubts. So unless I get a clear concept, I cannot move. That is the one of the reason I don't teach much number of subjects. So that is the reason I give more importance to your doubts. Okay. I know some people hesitate, whatever. My students should get all clarity. That is what I can try. Remaining is up to you. But so see here. Oh, firstly, it is a IO mode. IO mode. Okay. So port A is used as input port. Mode 1. Port A is input port. Port C upper is output port because to give this, to give this, to give this. Thank you, Asif. And now port B is mode 1. It is a output port. This is also okay. Let's see it is correct or not. Let's go. You remember the format or not? This is. Please see here. I will explain betterly. It is a port C is a output port and mode 1. Mode 1. This is port A is output port. Port C upper is also sorry not output port. Na. 1 minute. Input port. Port C upper is also is a output port to give the SOC signal. I use it as a output port. And this is mode 1, port B, IO mode only. And this one, port B, 7 segment display is connected. It is used to give output. Port C lower is used as input. Why port C lower is used as input, sir? Tell me. To read end of the conversion. Very good. To read end of the conversion, we used port C lower, PC0. Okay. So this is 05 and 1011 mean B5. Sorry, it is mode 0 na 1 minute. It is not mode 1. It is basic IO mode only na. So what is that? It is mode 0. So 1001 and 0 1 minute. 1 minute please. Port C upper is giving SOC. This is mode 0. Port B output mode. Port C low. Now I will explain. Tell me. See here. It is a IO mode. Port A and port B are connected in mode 0. Mode 0, just listen, okay. Mode 0. Now port A is reading the data, okay. Port C upper is used for what? Wait, let me check. Port C upper is PC7. PC7 is used as giving the data. Giving the data means output. So port C upper is used for output. Okay. Next, this is mode 0. Port B is output. This port C lower is input. This is correct. So what is the answer? 8 and all zeros and 1, 81. 8 or 1? Okay. Tell me what is your doubt. See this figure. Port B, output port or input port? Tell me here. Port B is output port. So 0 I will keep. Is it okay for you? Next, port C lower. Port C lower is used to read the data. So it is input port. This is a mode 0. This is also mode 0. Port A is used to read the data. Read the data means 1. Read the data means 1. Next, port C upper. Port C ka upper part is used to give the data. To give the data means 1. Sorry. Give the data means to give output. Right. So after reading this 1001, this is 9 and 1. It is a all are mode 0 only. All are mode 0. Just basic IO mode. No handshaking. It is a basic IO mode. No handshaking. Tell me any doubt. Ruchita, what is your doubt? Output equal to 0 but below D1 IO pointed is 0. What is the doubt in D1? D1 means 0 means output. 1 means input. Okay. Forget about this here. This is same. 1 minute. You are worrying about this. It is a printing mistake. This is 1. Okay, happy? Every time 1 is input, 0 is output. Okay. Finally, you are happy. Then I am also happy. Thank you. What is M0? Mode 0. Mode 0 is the basic IO mode. We discussed here. Na? It is used to transfer the data input and output without any handshaking. That is what we are using here. That is what we are using here in this figure. So control word register must be equal to how much? Control word register must be equal to 91. So 9 and 1. So this is 91 is the data. You should keep it in control word. Now please listen here. Address bus A7, A6, A5, A4, A3, A2, A1, A0. They can be 1 all zeros. This will give you what is the address? 80. Okay. This is for port A. Now, A part is always fixed. Now, these bits are changing. So, if it is 01, it is 81 port B. It is 82 port C. And this is 83 CWR. So, for the computer, CWR is connected at which address? 83 hexadecimal. For computer, CWR is connected at which address? 83 hexadecimal. So now what I will do is very simple. See here. How to write the program I am showing you. 1 minute. First, load that data. What is the data you have? 91 hexadecimal. This is to be sent to whom? Control word register. Okay, 8255 control word register. So to send this data control word register, what to do? Control word register is at the address of 83. What is the instruction you can use? What is the instruction you can use to do this job? Very good. Out. What is the meaning of output 83H? Your control word register is copied with 91 hexadecimal. That is the contents of 83H is copied with the contents of accumulator. 83 mein what you have is CWR. So first CWR format ko set kiya. You understand now, you technically able to understand what to do. First part is done. Then what to do? We should generate, start the conversion. Start the conversion ka matlab kya? First you should give 1 for some time and you should make it 0. Which bit is to be do? Which bit is doing that job? PC7 is doing that job. So please listen how to do that. PC7 is doing that job. Okay. So make PC7 bit is equal to 1. So MVI A comma 80 hexadecimal. What is the 80 hexadecimal? First bit is 1. Okay. Then out 82 hexadecimal. That is PC7 will be equal to 1. Port C may you get this 80. In that PC7 is how much? 1. You understand this or not? Please tell me. What is the doubt, people? Please listen. 80 is here number. 80 means 1 followed by 0, 0, 0, 0. Isme 7th bit is 1 na. So out 82. It is address here. In this address, what you have? 82 address mein what you have? Port C. 82 address mein what you have? Port C. In port C, you will get this data. That is first bit will be made equal to 1. Similarly, starting also same thing. First move this control word register mein whatever you want to write, the data should be loaded into accumulator. Then out 83. 83 is not number, it is address. In this address you have what? Control word register is already connected. So that control word register will get 91 hexadecimal. Now you understand or not, everybody? Okay, so port C is there. So now call delay. Okay, then MVI A comma 00 hexadecimal, and then what happens? Please listen. It is 1. These 3 bits will do like this. And what is that? Out 82H. Then here PC7 will be equal to 0. So this part will do this job. What is the job? It will, up to the delay, it will be 1. And after delay, it will make it 0. This is what we call SOC signal generation. So how to write the delay program, sir? At delay, same, we have done MVI, some which register is not used, use that, some H comma FF hexadecimal. Loop program. MVI L comma FF. Okay, and then decrement C. Okay, NOP jump no 0 to loop 1. If not, return. Like that we can write. You can increase this size according to yesterday calculations also we have done. So whenever you call delay, it will go there. After it will waste some time. Now you understand why to waste the time. Then come back. and send 0 to the port C. So start. Okay. Now what happened? First part is done. What is the first part, sir? Start, what we call start of the conversion is given to your 80, what is that? ADC. Now we should read what is that, whether conversion is completed or not. How computer will know whether conversion is completed or not? So it should read PC not, check whether it is equal to 1 or not. Okay, it should read PC not and check whether that particular data is, what is that, 1 or not. So what to do that for that? Okay, so for that what to do is simple. In 82H input 82 hexadecimal. Okay, now how to check LSB is equal to 1 or not? You should tell me this. I need to read PC not. How to read? Suppose port C got my data now. So in the port C, for example, how to read PC not? Okay, you don't know other bits now. Yes, rotate. You need to read only one bit, so rotate it. So last bit is to be read. So what to do? You can do XOR also. That is also good, people. Or you can say rotate accumulator left through carry or without carry, whatever may be, such that your leftmost bit will be going to carry. Leftmost bit will be going to carry. Leftmost bit will be going to carry. Then you take this as loop 2. Okay, rotate accumulator left, that is read it. Then jump if no carry to L2. Okay, if there is no carry, that is rotated now, 1 is not coming. Okay, rotate accumulator left, that bit is entered into what? This PC not will be copied to carry flag. Okay, so if that bit is not equal to 1, what to do? Again you read it until it becomes 1. Continuously we will be reading. So it will take 40 state, then 10 state ke baad again I will read it. If you don't want to read continuously, you can keep some delay also in between. It is optional. Okay, so you go back to loop 2, whether it is correct. Okay, when it is becomes 1, that is when you get 1 here. Okay, then what to do? You should understand conversion is completed. So this bit and this bit are used for checking end of the conversion. So when it is done, then come out. Now what to do? Data is ready at where? Your output of the ADC. Because we should not read ADC while doing the conversion. This we discussed in the data converters. We should read it only when the conversion is completed. Okay, so because of that, so conversion is completed. Then what to do is, please listen here. In where you have port A, 80 hexadecimal. Port A. Okay, in 80 hexadecimal. Now your accumulator got the data. Then what to do is out 81 hexadecimal. Out 81 hexadecimal. I didn't understand, Aditya. Please show 82H address. Okay. So this is given to port B. So halt it. Halt or jump to start. Why to jump to start? After delay. It is up to you. Then what happens after again sometime it will sample the data again. Rotate accumulator left, leftmost bit, that is LSB is copied to accumulator. Accumulator is containing PC, in that LSB will be copied to carry flag. That's all, Rahul. Rotate accumulator left means leftmost bit will be copied into carry flag. This leftmost bit, rotate accumulator, right? Yeah, correct. Right. Okay, now you understand how to do the interfacing. You got the real time feeling. You made something. So you can do interfacing of keyboards, etc. in microcontroller. Now you can download from internet interfacing of keyboard of microcontroller, etc. You will be able to understand. Even it is not 8085, you will be able to understand. Okay. Any embedded programming, anything you see, you will be able to learn. Yeah, virtual compilers are there. Use of BSR. BSR is used to reset or set only port C. Port C ka bits are there na. Port C is having PC7 to PC0. Those bits can be made 0 or 1 using BSR mode. It is of no use, I mean, other than this bit set reset mode. It is to set or reset the particular bit of the port C. Okay, you can use it if required here. You can make it as in the BSR mode and send PC not equal to 1. That is also possible. Okay. Yeah, starting you need to reset it. I assumed all are in the reset. Otherwise, yes, you can use BSR mode and reset the port C bits initially. If you want, you can do it. Or after this system is done, once PC1 is done, we should clear it. For resetting, you can simply copy accumulator equal to 0, 0, make PC equal to 0. It will clear it. So initially, if you want, you can clear. You can improve the program like anything. Nothing wrong. So is it okay? Shall we move further? I am giving you one homework. Write a program using 8085 to generate triangular waveform or ramp at output of port A. Any port you take, it is you. Use your 8085 to write generate. Simple. I will give you hint. Shall I give or not give? Use counting. Initially you make 1, next you make 2, 3, 4. Okay, automatically your output will increment. After 7 or something, you make it 0 again. So 1, 2, 3, 4, 5, like that you generate the output continuously. Give delay between one to another. Like that you can do it. So you can generate square wave also. Call delay. Calculate the delay according to your time period required, depending on the processor frequency. So I will come to Aditya doubt. What is your doubt, Pupul? Tell me, what is your doubt? If you want, you can reset initially. Here, nothing wrong. Port C can be resetted initially. You can reset port C by using. Okay. If you want to reset, you can reset initially. You set this in the BSR mode. BSR mode mein kya? It should be 0. It can be anything. Then what to do? You want to make port C7 to be 0. That is, you make these 3 ones. You want to keep 0. Then this can be anything. So it is 0 and A, B, C, D, E. So keep this OE in the accumulator and send to the output whatever where you want a control word register. Then move A comma whatever. Automatically this will do this job. This is enough. Here in place of this you keep this. or you want to reset blind way also. What is that? In port C, you are sending the data. First send 0, then send 1. Okay. See here. What is that? Your conversion is sent SOC. Then we should wait for EOC. For EOC, what I am doing is continuously 1 minute. I am very sorry. Why I did this? I should not LAR. I should read from here. That is, I should read it, rotate the bit, check the carry, not there, again read it, rotate it, check the carry, again read it, rotate it, check the carry. Is it clear, Aditya, now? Once you get the carry, then read the data of the port A, then give it to the port B, that is display. That's all. Okay, shall we move further? Okay. Now, thank you. Now, mode 1. Let's see mode 1 also. Mode 2 will be very lengthy. We don't need it. Actually, if you understand what is called 8255 architecture, it is sufficient earlier days, but now it is not at all in your syllabus. We need not say anything for this. But still we discuss it. Okay. How mode 1 will work, let us discuss it. Then we can leave the class. Then EC people can stay for SRAM DRAM discussion. Yeah, in AC actually not only 8255, you need so many other stuff also. 8257, okay, 8237, all those peripheral interface devices are required, and 8086 also required, not only 85. Okay, so leave it and now come here, but this will help you for ESC, no doubt in it. So listen here, mode 1. What is the name of mode 1? Strobed IO mode. In that first I am discussing in, then wait, shuffle हुआ. Today class, why it is named as doubt clearing session? Tomorrow you have exam? So I need to give some paper. Okay. Okay. So strobed IO mode, in that first we are discussing Ria. Strobed input, then we discuss strobed output. That will finish your syllabus. It is not in syllabus anyway. Okay. So strobed input. In this case, what happens? Okay. What happened to you, Aditya? Listen. This is port A. This is port B. So in this, please listen. In the strobed IO mode, what I told, let's go back. In the strobed IO mode, port A, port B can work. Port C is used for providing handshaking. Observe here. Okay. Port A and port B can be used for what? IOs. They can be used as input ports or output in the mode 1. But who will help us for handshaking? Now port C will help us. Okay, maybe because the port C is having this handshaking support, because of that it is having that extra feature to set or reset it. And another case is why it is not possible to take all the ports in the IO mode. It is not possible because there should be one port to sacrifice and take care of these signals. What are those signals? Strobe, what we call this handshaking signals. For handshaking signals, you should have one device. Okay. So now listen here. So who is helping us for that? Port C. So please see here. First you get a strobe. You are, please listen. Input ka meaning kya? You are reading the data. You are reading. System is reading the data. So first CPU, sorry, external device will give the signal strobe. Okay, external device will give the signal strobe, active low signal. Whenever strobe comes, the computer will read the data. That is, port EMA data is kept. We understand which language. Please listen. Please listen. So data is kept here. Data is ready. Okay, see here. Data is there. Okay, data is ready, and I will give strobe. Okay, मेरे पास data है. Please read it. I am giving that with the help of signal called name क्या? Strobe. Strobe will say that मेरा data ready है port में भाई. Please read it. Load करो. Load it. Load is available. Please load it. Okay. So then this who will take care? This 8255 will do it. This part. Okay. It will read it into its buffer and it will say, okay, I have stored it in my buffer. You can do your job. You can remove the data also, no problem. So so it will say input buffer is filled. It will say input buffer is filled. Okay, then what happens? Listen here, input buffer is filled. Then what happens is after input buffer is filled, strobe is gone. Strobe is gone. What is the meaning of strobe gone? Data is written. Data is whatever you want to write, the data is gone and the input buffer is full. Then what happens? We generate one interrupt to the computer. We generate one interrupt to the computer to say that data is available in the buffer by please read it into your computer. Then CPU will respond to the interrupt. CPU will respond to the interrupt by sending read signal. Okay, bye. I am reading your data. This is the process step by step you should understand. What is the first step? Data is stored into the port. Okay, data ready. Okay, data is ready. I send the stop signal. Okay, then what happens is I will give you the signal called IBF. Input buffer is full. Okay, input buffer full. Okay, then what happens once your data is stored? Then what happens is we will generate interrupt request to the CPU. To whom we generate the interrupt request? CPU. Then CPU will respond to the interrupt with the help of read signal. Whenever read comes, interrupt will be disabled. Please understand like this. Outside PC3 may I am sending interrupt request. I means this 8255. Whenever computer respond with read signal, okay, I am reading by. Then what happens? This PC3 will cool down. Okay. So interrupt is like that. Okay, it is throwing. Okay, please read. To the read bar signal, it may be interrupt technology. This read bar may be connected to interrupt technology of the computer. It is possible. Okay, so whenever it gets the read bar signal, it will understand. It may be end operated with the interrupt technology signal. It is you can connect it in any way. Whenever CPU send the read bar signal, okay, to the 8255, it understand. Okay, my interrupt request is accepted. Okay. Now you understand how the data will be taken with the help of handshaking protocol is the, you understand or not? This is giving the data. Next. Okay. Now first we read the data. Now we are writing the data. So first we are writing the data. Computer will generate write signal. Computer will generate. Firstly, listen here. Input buffer is full. Okay. This will be given to the IO device. Okay. Now, so here let us see how to understand this. First, understand an interrupt is generated to the computer like that. I am free. Please write the data. I am free. See here, OBF bar is 1. What is the meaning of OBF bar is 1? Output buffer is not full. Output buffer is empty. Output buffer is, yes, output buffer is empty. When output buffer is empty, we send the interrupt signal. We send the interrupt signal to the system. We send the interrupt signal to the system to write the data. Whenever I get the right signal, immediately whenever I get the right signal, my interrupt request will be gone. Okay, interrupt request will be gone. Okay, then the data will be, once this is the during this period. Okay, during this period you are writing the data. Once you have written, output buffer is full. Once you write the data, your output buffer is full. Once output buffer is full, external device will give you acknowledgement. Okay, I am reading the data. Once you get acknowledgement, you can remove the data. Means it has read the data. Acknowledgement is gone now, so it has read the data. You can remove it. So I will explain it again. Please listen. It is just a reverse process of previous case. It is a write operation. Okay. So firstly, what happens is when CPU is ideal, I am ready to read the data. I am ready to accept the data. I will send the interrupt. Then system will accept. Okay, I am writing immediately. Okay, you just this can be front or back, so that's why arrows are given like this. Okay, so I am okay. Okay, it is writing. Then what happens is interrupt will reset. Then what happens, the CPU will write the data. Output buffer will be full. Then external system will send. Once output buffer is full, the external system will get the acknowledgement. External system says that, okay, I am reading the data. Until that, you should keep the data available. Okay, so data is sent to the port. Acknowledgement got now. Okay, data is transferred. So for this, who is helping us? Port C again. Port C ka 3 bits are used. PC6, PC7, PC3, PC0, PC1, PC2. These two, PC4 and PC5, can be used as normal IO bits, but 6 bits are required to do this job for port A and port B. Similar 6 bits can be used here also, but not same, but different 6 bits can be used. You know how to model it as a IO port or input port, output port. So this is how computer can communicate. That is the use of 8255 to generate this kind of communication between your computer and what is that? IO devices. We take the help of your 8255. Yes. Any kind of doubts, you feel free to ask. Then otherwise we can call it as day for 828085. Who is S. J. Shankar? Okay. So now come to digital. We'll wait for a few minutes. Shall we refresh? Anyway, you people are there in networks. We will be meeting, so nothing to worry. I need to acknowledge. SRAM and DRAM. Yes, course is done long back, Sonali, because now it is not there in Gate. Chocolate, you want to make some noise, you can make it. You people, all of you are coming to networks or already completed networks. Bye, Alicha. Good. We need not call him. If we are late by some time, he will call us. Okay, Rahul. When you watch recorded, I will tell you one thing. Please listen. When you watch recorded, don't be regular for those classes also. Don't because you are watching regular. Don't see whenever you feel mood. Make it as a schedule and watch it regularly. And I have one great doubt for all of you. How you people understand machines without knowing networks? Not only machines, power systems or power electronics or analog, anything. How you people understand that without knowing networks? If you already know something, it is okay, fine. Otherwise, you will feel little difficulty. Yeah, that's what I'm saying. Okay. Oh, you took coaching already. Good. Okay, fine. Okay. Today I got one phone call. Uh, he want to prepare for a gate time. He is feeling some difficulty. Yeah. What is the difficulty he's feeling is he's studying. He is able to understand what I mean the problems of the class, but not able to do any single question, new questions. I asked him how you have studied. He said I studied from some coaching. He said how is that coaching? I asked. Okay, I don't say any name. I don't blame anyone at any point of time. It is not my habit wherever I am. But general, I asked him. Okay, good. How is the classes going on for you? He said it is very well. Then I asked him. Okay, then why are you not able to solve the problems? Sir, I'm not able to understand the classes, he told. Okay, if you don't understand the classes, then how you said the classes are very good? Then he replied that, sir, I see how they are teaching good problems or something like that. So I thought they are teaching good. So this is how you measure the feedback in general. Okay. So you will be having some expectations, or your friends decide you will say this faculty is good or this classes are good. Then automatically you will have something in your mind. Even you don't understand also, you feel that the faculty is teaching very well, but I am not able to understand. But if the faculty is very good, he should make you understand the things whatever he teach. This is what I feel personal. That is what the meaning of good faculty. Okay, good faculty can, I never try to impress you in the first session. I start very slow, everything. Okay. But we can impress you very easily in the first few sessions. The latter you feel faculty is great. I am not able to understand. That should not happen. Please don't be in that kind of state. When you attend any class, general suggestion I am giving. Okay. I don't want, please people don't deviate it, don't make it controversy. I don't like to, I mean, don't give the names and all those things. I respect everyone, whether this institute or any institute. I never involve in those kind of things. I'm just giving a suggestion when you attend any class. Okay, please make you comfortable. Don't have any pre-expectations or anything. Just you are able to understand or not. That is the parameter. Faculty look very young. Okay, faculty looks like very experienced, very old. All those things you never keep it in your mind. Okay, thank you, Bukul. All those things never, you attend any single class happily, you are able to learn from that or not. Only this is the parameter you should measure. So because it is a last class, I mean it is not a last class, we'll be keep meeting regularly, don't worry. Yes, Aditya. I should enhance your problem solving skills. That is what I try always. If I teach tough problems, you will be impressed. But I should teach you how to solve tough problems. Okay, Surya, thank you. Oh, nice, Asif. So, shall we start the semiconductor memories? Easy guys are there. Any easy guy is there or not? Thank you, Sonali. Yes, Ganesh is there. Ritik is there. ESC may also it is not there, Rohit, as per my knowledge. I have checked the syllabus. Thank you, Sonali. Two students are there. That is enough. Ganesh, I will show him when we take some Facebook session or somewhere. In the personal sessions, we can show you. No problem at all. Aditya, you are multi-branch. So let's move to SRAM and DRAM. Ready? So let me check how many students are easy. Yes, Aditya, very good. You are giving EN. EN, I think it is there. Don't say all. Let's remove D option. I am searching for option A. %. A is correct because I am searching for A. How D comes? Because they don't like to make it 100%. So 5% D also there. Good. So let's start. Happily, you can talk to me, Aditya, at any time. So listen here. Let's talk about SRAM. Okay. Shall I draw the figure? Okay. What is SRAM? Firstly, basic SRAM का meaning क्या? It is static RAM. Okay. You need not, ideally, you need not charge it once you store the data. Once you store the data, you need not charge it. What is DRAM? This fellow is dynamic. Here, some periodically refreshing the data is required. Periodically refreshing the data is required. So now let us discuss first SRAM. Both are volatile memories only. Both are volatile memories only. So SRAM का story क्या? So let me draw this figure. Okay. For your better understanding, you remember flip-flop or not? You remember flip-flop or not? Flip-flop में how data is stored? In flip-flop, how data is stored? Here, not voltage and current. It is two inverters connected back to back. We discussed this or not? Yes, this is fundamental of SRAM. What is the fundamental circuit of the SRAM is this one. It is like a latch. There are two flip-flops connected back to back, can store, can lock the data. This is the fundamental circuit of your SRAM. So in that SRAM, why SRM, I write? SRAM. Okay. Oh, Ruchita, you are from Kakinada? SRMT. Yes. So where are you from? Okay, fine. So SRAM, the fundamental, this is the fundamental unit of the SRAM. You are from JNTU Anantpuram. Okay, very good. So many people from JNTU and etc. and nearby surrounding. JNTU H. Oh, nice. What we are discussing here, there are different variations are there. In the SRAM, you have 40 SRAM is there, 60. This is, please listen, it is a heart of VLSI. It is like heart of VLSI. As an engineer right now, if you are becoming a VLSI engineer, if you design a best SRAM, what is the best SRAM, sir? You improve any specification. What are the specifications we are having, sir? Propagation delay, power dissipation, any specification your design is able to implement or improve it, then you can get one paper or your research will be selected or you may be getting some patent also. Okay, so a lot of work regularly going on this SRAM because it is having, it will be what you use it in your cache memory and all those things. So different variation, 12T SRAM, 12 transistor SRAM is there, 4T SRAM is there, 60 SRAM is there. What is that? 60 means 6 transistor SRAM. You can do your final year project or whatever MTech project, all can be done on this. Here we discuss very little part of that. Very little part with respect to our digital subject, we discuss it, but it is very huge. In fact, it is one semester subject also. Not one, Aditya, you need two capacitors. It is one semester subject also. Okay, so let's move. So take one inverter. Okay, you know what is inverter, right? No problem, Ganesh. You know what is inverter? CMOS inverter. Okay, so this is what you are having. Yeah, DRAM is one transistor plus one capacitor. Correct. So you have this. Now, for this, okay. So now you need to connect them back to back. Back to back meaning you just realize this figure. From this figure you connect it. Output of one connect as input to the other. So its output you connect as input to this, and its output you connect as input to this. So this is Q1, Q2, Q3, Q4. Okay, so this is 4 transistors are required here itself. Now externally you require. This figure is clear for everybody, right or not? 2 inverters. You can realize the 2 inverters connected back to back. Yes or no? Right. Very good. So now here we take 2 more transistors. Means right logic. WL का meaning क्या? Right logic. And here you are having bit line, bar, and bit line. Okay, so this is what we call 60 SRAM. 60 SRAM. I'll come to its working very clearly. Okay, very clearly how to write the data, how to read the data, everything we will discuss it. This is called bit line. This is called write logic. Okay, how you store the data is like a flip-flop. It requires 6 transistors. There are some variations in this, like I will show you. Just wait. What is the meaning of 40 SRAM, sir? It is a 4 transistor SRAM. Okay, 1, 2, 3, 4. These are made with resistors. This is an example of 40 SRAM. What is the meaning of 40 SRAM, sir? It is a 4 transistor SRAM. Okay, 1, 2, 3, 4. These are made with resistors. So better noise improvement and all those things in the CMOS, we go for this design, which is the 60 SRAM, where this active pull-ups are taken instead of that passive resistances. That is CMOS design is made instead of this NMOS. Yeah, it is bistable. Not looks like it is bistable only. It is bistable only. Okay. No, it is actually, if you use active pull-up, you can make this is a always on type of condition. If required, we can make it. Here, this is a CMOS logic. Here, any one of them is on at a time, not both at a time. Here, any one of them will be on at a time, not both of them will be on. Okay. So now see here. What is DRAM? SRAM, I will explain. Just let me complete DRAM, the difference you understand. Then we'll come back to SRAM. I'll explain what is, how to read it, how to write it. Same means working function of this. What is the meaning of BL and what is the use of WL? I can explain that. I will explain it. Just for time being, for continuity, roughly how to understand, it is a 2 inverters connected back to back. It is 2 inverters connected back to back. And see here, this is the right logic. So this SRAM can do 3 jobs. SRAM can do 3 jobs. SRAM can do 3 jobs. What are they? Hold, read, and write. Hold ka matlab just your flip-flop condition only. It will hold the data as it is. It will hold the data as it is. That is hold. Okay, storing the data. You can read the data also. You can also read the data, or that is already stored content, or you can write into the SRAM also. 3 jobs you can be able to do it. For simple logic, if you want to hold the data, just make this 0. Just make it 0. If you make it 0, what happens? This part is off, this part is off. So you cannot access this. These are called access lines. Okay, you cannot access transistors, you can say. You cannot access the data of the what we call SRAM. You cannot disturb it. This is called as hold condition. For hold, what is the condition you can do? WL must be equal to 0. Up to this, everybody clear or not clear? Please tell me. Up to this, it is clear or not? Right. Very nice. Very nice. Now listen here. I'll come to that read and write operations also. Before that, I want to what we call explain DRAM also. Then I will come back to that. DRAM. Here, data is stored just like this. Okay, this is what we call basic DRAM cell. In this, what happens? Okay. So now let us see what happens when you write different data in this. For example, if write logic is 1, if input is 1, this capacitance, it is not physically visible capacitance. You can say this internal capacitance or stray capacitance, whatever we call, this will charge. Okay. And if your write logic is 1, your input is 0, what happens? This capacitance will be, tell me, capacitance will be discharges. So by charging and discharging the capacitor, we will be able to store the data. You will be able to write the data 1 or 0. When it is 0, whatever may be the input, it cannot disturb this transistor. It cannot disturb this transistor. That is, here we are using the help of what? Input capacitance of the transistor. Input capacitance of the transistor to charge it or discharge it. But here, some cost reduced because less number of transistors. Less number of transistors means less cost. So unit cell may it requires less space also, less cost. But the disadvantage here, capacitor, you are using capacitance property, which is not much faster as SRAM. Capacitance will not what happened? Yeah, cannot change instantaneously ideally. And another thing you can see here, any capacitor will have some leakage conductance. Any capacitor will have some leakage conductance. Because of the leakage conductance, there is a chance, there is a chance that it can decay over a period of time. Once you charge the capacitor, you don't disturb it. Because of the leakage conductance, charge will decay and it may become 0 over a period of time. So that is to avoid that we need to periodically refresh this circuit. That is periodically you should keep some charge in the circuit. That is one extra burden in this case. Okay, these are small disadvantages, but it is a cost effective. It is cost effective. Now let us see one important objective. What is that? Differences between SRAM and DRAM. Differences between SRAM and DRAM. So let us see. Is this point clear, everybody? Please tell me. Is it clear to everyone? Good. Now, remaining, I don't think much are there from EC. For what purpose you need more transistor here? Tell me, Aditya. You don't need any extra transistor. I said one now. I said two only. Okay. So now see here. SRAM and DRAM. Oh, you have not what we call attended earlier class of semiconductor memories. At least you might be studied MOS also in analog. For electrical, it is there na analog. Oh, then no problem. So let's start with SRAM. Okay, here how the data is stored. Data is stored like a flip-flop. Okay, here data is stored. How you store the data here? By charging and discharging capacitance. These points are important. Exam point of view, there are every exam in ESC, one question compulsory comes from this table. I don't predict, but generally it is the trend. It is the trend most frequently occurring. So this is one point. Okay, next. Each cell or bit of SRAM requires 6 transistors. You can make it with 4 also, I told already. Each DRAM cell requires how many? Very good. 2 transistors. Costlier. Yeah. Cheaper. Not cheaper. Comparatively cheaper. That is compared to SRAM, DRAM is cheap. So next. Faster. Relatively slow. Okay. Next. These points, everybody clear? All these 4 points? I have not typed. Okay, these days little busy, because of that I'm not able to make the slides. So anyway, we can discuss and write. Okay. So now listen here. Here we are. Another few points which are important. Using transistor or MOSFET. Because bistable multivibrator flip-flop circuit, it can be made with transistors also. But it can be implemented using, what is that? Using only MOS. Only MOS can implement it. Right. Next. Listen. It is volatile memory. What about this one, sir? Tell me, what about DRAM? Yeah, DRAM is also volatile one. Okay. Next. Here, packaging density less, that is less number of cells per area. Here packaging density is more. More DRAM cell can accommodate in the given area. Okay, so next, again, last points. Right, see here. These are the points covered. Okay, next, yeah. It is used in CPU cache memory. It is used in main memory. Anything else? Yeah. More bandwidth, less bandwidth. Yeah, very important. Periodical refreshing not required. Here you don't need periodical refreshing because capacitor not capacitor, it will not charge discharge. Here what is that? Periodical refreshing required. Okay, first case periodical refreshing is not required, second case it is required because capacitor will discharge over a period of time. Is this points clear? Right, so we are in the end of your syllabus. Around 10 points I have given. Main memory are for purchasing your system. See what is that, 3 KB RAM, 4 KB RAM, you ask na? Sorry, why I am saying KB, GB. Whatever you are asking, your RAM size, that is nothing but in the main memory only. Generally in the computer what happens, when it access the data, it will keep it in the main memory so that it can access fast. That's why your RAM size is more, your system will perform faster. Why? Because you know this memory organization, right? You have external memory, to access it, it requires more time. Normal hard disks and all. Okay, comparatively, this RAM part will take less time. So whenever you access one data from a particular location, computer will assume you are going to access the next locations also. It will keep it there in the nearby. Okay. As if even I don't know that. Where this graphic card is interfaced, I'm not sure. What is that, Aditya? Yes, correct. Multi-channel also I don't know. SRAM is cache memory. In computer organization, you will study this. What is the meaning of cache memory? In the CPU, to save the time, it will keep some data with prediction. You are going to access this data. Okay. So when you are accessing some data, CPU will keep some data with a prediction. Okay. You are going to access it. But if this prediction is satisfied, we call cache hit. If it is not satisfied, cache miss. Not because every time you may not access the sequential data. So the most frequently used are there is a most probable to access that data will be kept in the SRAM to improve the performance of the CPU. Okay. So now let's move to the last part, that is what we call, I need to copy paste this. Okay, I will do one thing. So let's discuss a little more about its working. Yes, Ganesh. Actually, there is this terminology is used in an interchangeable way also. Like suppose these days, whatever you are having the memory of this, what is that? Actual, what is the meaning of RAM is random access memory. Any memory which is having faster access can be called as a random access memory. Okay, random access का meaning क्या? You are able to go to any location in the computer. You are able to go to not computer, sorry, memory. So whatever your disks and all those things, these are semi-random. These are semi-random. Cost, Ganesh. You need a cost-effective solution. That's why you purchase the mobile when RAM size is more, it requires more cost, obviously. Okay. So now let us see how to hold the data we discuss. Then how to read the data we will discuss it now. How to read a data from the SRAM. How to read the data from the SRAM. So for reading the data, what you use is here we use some charging. Okay, this is according to your exam may not be required, but let's discuss. Okay, so this is a capacitor. This is also another capacitor. Now these are called pre-charged capacitors. We'll use this pre-charged capacitors. Okay, so these are called access transistors. Access transistors. Let me give the name Q5, Q6. Let me give the name Q5 and Q6. Now let's assume any data. Randomly you assume some data. Q is equal to 0. Q bar equal to 1. So you want to read the data which is already stored. What is that? Q is equal to 0. Let me take. Q bar is at 1. Okay, this is the condition already existing. So please listen. When Q bar is 1, okay, this transistor will be on. Okay, because this is 1, this transistor is on, this transistor will be off. Because it is 0, this transistor will be on, this transistor will be off. Is it okay? First part, up to this, is it clear or not? So now what happens? So now these bit lines are used as a input lines. Now these bit lines are used as input lines. Now what happens? See here. Now the capacitor here 1, here 1. What is the current? 0. Okay, but here 1, here 0. What happens? Tell me here. Yeah, discharges. When it is discharges, when it is not discharging, here we have one device called sensing amplifier. If you are able to understand, okay. Otherwise, actually, exam point of view, you don't need this much, but we'll discuss. You will be able to understand. So whenever this happens, your sensing amplifier will sense it as 0. So let's take the same condition for 1 also. Okay, let's take the same condition for reading 1. You want to read 1. Okay, then what happens? Tell me. Tell me here. Any problem? Please comment. If you have here 1, here 0. Similarly, q equal to 1, q bar equal to 0. If q is equal to 1, q bar is equal to 0, then what happens? Tell me. So this fellow will discharge, and this fellow will not be doing anything. So based on this Q2, Q4, which path is coming, based on that, you will be having some sensing amplifier circuit here, which will take its difference and sense whether it is 0 or 1. Whether this is greater than this or this is greater than this, based on that, it will decide. Is this clear? So whether it is coming from here, from here, based on that, it will decide. So that is how your read operation is going to be done in your 80, what we call, SRAM cell. So now I'll ask you one question. Let's try to answer. Yes. Yeah, these are external part, not part of your SRAM cell. Read this question. I'll conduct a poll. Carefully read it. Are you ready? Remaining. Okay. So here is not much difficult, but it is given in one of the gate paper. Let's start the poll. 100% I expected. What happened? Why 60% only? Actually, there are no previous questions I am having from this. What happens? It is stuck. Poll is gone here. So 60% only given. It is a straight away question given in GATE 2014. This is a GATE 2014 question. So what is this? Inverter. Okay, you should have back-to-back connection of the inverter. This is the right answer. What is the confusion? Why people committed wrong? Please tell me where you are wrong. Why you are wrong? Oh, you also got 1 mark. Don't know and mark it randomly. This is not correct. Okay, so let's lastly do one more thing. What to do? I need to copy this figure. Okay. Okay, let's copy this figure itself. One minute. So lastly, I will explain right logic, then we can end the class. Okay, so this here I want I want to explain write operation. So when you want to write the operation, that is, you want to write, for example, you should make WL is equal to 1. Okay, so let's take this as Q bar and Q. Okay, Q bar and Q. You take already existing any value. You take already existing any value, either 0 or 1, whatever. This is pre-existing. Okay, now you want to write, for example, it is already having 1. You want to write 0. What to do? Simple. Okay, you may have some capacitor. Don't worry about it. It is used for writing. Okay, reading or writing. It will help us. Now, simple way is connect this to ground. Connect this to ground. What happens? Tell me. Yeah, this will on. Okay, and this will on, and the what it is having higher potential, it is having lower potential. Okay, it will discharge, or it will discharge through this path, and it will become 0. When it becomes 0, this 0 will come here. Okay, then again, where is that? I'm sorry, this is 0, right? One minute. Yeah. Oh, 8 minute. 1 minute. Yeah, this becomes 0. When this becomes 0, what happens is, this is the input to this transistor. This is not 0 now. So 1 minute please. Let me write clear. This is 0 and this is at 1. This is the initial thing happened. Now what I am doing is, I want to discharge it. I want to make it 0. Then what happens? I will discharge and make it equal to 0. Now this will act input to these two transistors. Then what happens? This is 0 now, so this will be on, this will be off. When it is on, this 1 will come here and it will change this value. Then what happens is, it will make the condition to be reversed. That is, this 1 will come, this will be off, and this will be on, and this will be grounded. Ground ka matlab kya? Ground ka matlab kya? We will make it equal to 0. It is a simple writing the data into the what we call flip-flop methodology. Nothing difficult. Okay, so this is how we can write or read data or hold the data in the SRAM. To hold the data, what is the simplest way to do? Hold the data, you need to just make WL equal to 0. Okay, I just explained very small part of SRAM. It is a very big design which you need a lot of things. See, generally this pre-charged are required when you are reading. Okay, or even you have a pre-charged here. Okay, if you connect ground, it will be discharging. Okay, but here this may discharge. One may discharge, one may charge, because it will change now this to 0, this to 1. It depends on other end voltage. It may charge. Yeah, read part is done by sensing amplifier. Will be externally will be having it. Sensing amplifier will be there. That will take care of your read operation. Right. Anything else? So hopefully I will may take CO also, maybe required. So 1 minute. I want to give you a few things. Please listen. Number systems, integer and floating point. Okay. And what is that? These are the things which are new in the syllabus, and critical path, something that is nothing but what we are calculating the delays. So these things I take some extra class and add it. I will inform you that. Okay. For these extra topics. So these are small topics only, nothing to worry. I will take it. Okay. So integer floating is only for EC people. S and H is for W also. If they have made the syllabus little early, I could have managed it before starting MP or something. We could have managed little in a different way. So anything else? Shall we end the class? You want song? Aditya, I mean, I cannot promise you. It depends. Means depending on the schedules at that times, whatever is possible, those things I can take. Okay. Actual science, I don't have much time to prepare. I mean, to make the new subject, because for online, if I teach new subject, I need to make so much effort is required for making these slides, all this story. Now digital is done now. For Hindi batch, I can use the same slides happily. I can teach digital network. Now I don't need any effort, except any question comes we can solve. But new subject requires extra effort. If I find time, I mean, parallelly instead of not parallel with networks, and I need to do some my research work and also. So time possible, I will take it, because those syllabus is not much. It is simple only, hardly maybe 20 hours. May we can complete that part. Meanwhile, if you before that itself you want to complete it, okay, I will announce in few days whether I will take it or not. If I don't take, or if you want to finish little early, then go to computer science. Your subscription is having that advantage. Go to CSC classes, check for CO. Okay, if you want, I can suggest some faculty for you. Okay, Saho, I am waiting. So please listen. You in that first half is nothing but your syllabus. That computer science CO mein first half, yesterday class I told now, first half is your syllabus. So to prepare that, this is for EC people only. So if for ESC electrical also it will cover it. Okay, that's all for today. Aditya, shall I go with your permission? Can I end the class? What to do then? Happy weekend. Okay, Aditya. You want to give me some biryani? Good night, Mahalakshmi. Nice. Have a great weekend. Yes. Bye bye. We'll meet in Monday morning. So hopefully tomorrow I may not take any class. Bye. Good night.